Hey there, we're going to talk about some properties of logarithms. There's several of them. The main thing, I'm going to skip a little bit of this. The main one is here, here, and here. These three, I actually wish I would have arranged my notes so that they were all kind of together. So let's start with this first one here, and I'm not going to get into the proof and all that. It basically says if I have log base b of p times q, that can get broken up into log base b of p plus log base b of q. We've seen this multiply to addition before, if you remember this rule. Here we're going from multiply to add as well. And an example of this is here. You can see I'm multiplying two things together, and I can break them up into log base 2 of 8 plus log base 2 of 2. And we'll use these rules throughout the rest of this lesson. Next up, when we're dividing to the domain, the numerator one is the positive one, and then it's minus the denominator one. Once again, we've seen divide turn into subtract in the past, if you remember these rules. So here's division to subtraction. Again, exponents are the opposites of logarithms. And you can see an example of this rule right here. Here I'm dividing. So I can break it up into log base 5 of 125 minus log base 5 of 5. Our third rule says that when I have log base b of p raised to the k power, that k actually can come down in front and become multiplied. Once again, we've seen this before, where I have x to the a raised to the b power becomes x to the a times b power. So here we go from exponent into multiply. And an example of this would be here. We can see, that we don't have to worry about this down here, that that exponent comes down in front and gets multiplied. So let's use these rules. Oh, one more rule. We have change of base. The IFF that you see here stands for if and only if. That means if this, then that, and if that, then this. So it goes both ways. The big thing to pay attention to is here. So if I have a normal calculator, the only two bases that I can even think to use are log base 10, the common log, and then the natural log ln. So base e or base 10, those are my only options. So later we'll run into one where we have base 3 or something like that, and we have to convert it into base 10 or base e. So we end up dividing like this. We'll come back to that. Let's use our new rules. So you may want to keep the rules close to you here. So here we have ln of 2, ln of 3, and ln of 5 equaling these here. So you can see I'm dividing. So if we look back at the previous rule, divide means subtract. And 6 becomes 2 times 3, which gets further broken down with addition. So that's the first rule there. So this is going to be a plus b minus c. Here, we can bring the radical becomes a rational exponent, the 1/3 here. And the 25 can become 5 squared, and again we multiply the exponents. And that exponent, according to our third rule on the previous page, comes down in front. So we get 2/3 times natural log of 5, which is 2/3 times c, since that's natural log of 5 up here. Now 24 gets broken down. I did a little tree here. And it ends up being 24 is 2 to the 3rd times 3. So because we're multiplying, it becomes addition, and then that exponent comes down in front. And then there's our a and our b. A and b. So we're going to expand this a little bit. Here we have ln of cube root of x, which becomes ln of x to the 1/3 power, and that 1/3 comes down in front. Here I'm multiplying and dividing, so the multiplying becomes addition, the dividing becomes the subtraction, and then I take the exponents and they come down in front. So that 2 comes down in front here. We end up expanding it. This one's a little more complicated. So this is multiply and divide. Now here's the multiply. The divide becomes subtract. The multiply, I actually have 3 things I'm multiplying, so I get 3 terms that I'm adding. Then on top of that, this becomes this here, which means becomes 1/2 ln of x plus 1, with all of these being the same. ln of 2 plus ln of 3 plus here minus ln of x minus 3. And you can see why my wife is doing all the writing on these and not me. Much nicer handwriting than myself. I'm going to skip that one, and we're going to move on down to here. So we're going to go in the opposite direction now. Before we were expanding them to be big, huge statements, and here we're going to take this big, huge statement and condense it down to a single logarithm. First thing I'm going to handle are the exponents. So that 7 is going to come up and become the exponent. Now I have the addition, so that becomes multiply, and the subtraction becomes the divide. If there's a minus in front, it becomes a term in the denominator. For this one, I'm going to distribute the 1/3 here and here. I'm now going to take the exponents, the numbers in front to become exponents, so that becomes an exponent. And now I'm multiplying, so that I'm adding, so that becomes multiply. I'm subtracting, that becomes divide. And so here it is, all as a single logarithm. Here what's happened is I'm going to notice that I'm subtracting, and I have a 4 here, that becomes the exponent first. And because I'm subtracting, that becomes divide. And look at that, we can even reduce it a little bit. Here, I bring the exponent up. Now be careful, this becomes squared for both the 3 and the x cubed. It'd be easy to miss that 3 squared to become a 9. And that exponent comes up here. And then subtract means divide. So here we are. We could further write that out as log of 9x to the 6 to multiply the exponents over x cubed minus 2 to the 1/3. And we're going to use our change of base. I'm going to show you with a calculator how to do that. So this is base 6. So if you look back at the formula, here I changed it into base 10. So you'll see I'm going to use the common log, log of 120, make sure you close the parenthesis, divided by log of 6. And you can see I get my decimal here. Now I could have changed it into the natural log, ln of 120 divided by ln of 6. And you can see I get the same answer. So you can convert it to whatever base you want, it'll remain the same. This one also, even though we have crazy numbers, so I'm going to go, can you see that? Let's see, right there. So log of 5.3, again make sure you close your parentheses, divided by log of pi. My pi button is down towards, here it is, above the exponent button in this case. Close. We get an answer. And there you have it.